Hello student, myself Dr. Swapnil Jain. I am working as an associate professor in Department of Mechanical Engineering at Kalinga University, Raipur. Today we will discuss about the conventional manufacturing processes and the joining processes. It is a part of the subject manufacturing processes. So first we start with the conventional manufacturing processes. The topic of the conventional manufacturing processes encompasses various techniques used in shaping and forming materials into desired product. One of the primary methods discussed in the casting and molding, focusing on the metal casting processes and equipment. This involves the manipulation of molten metal to create complex shapes through solidification. The process involves heat transfer principles, solidification mechanism, consideration of shrinkage, riser design to prevent defects, identifying casting defects, and managing residual stress in the final product. The whole process of production casting may be classified into 5 steps as follows: pattern making, molding and core making, melting and casting correct composition of the molten metal, fatting the casting as obtained after solidification, carry unwanted projections, testing and inspection. Heat transfer plays a critical role in the casting process as it influences the solidification rate, affecting the material's properties and final structure. Solidification involves the transformation of molten metal to solid state, impacting the material's microstructure and mechanical properties. Shrinkage refers to the reduction in size during solidification, which necessitates thoughtful design consideration to prevent defect like voids and porosity. Riser design is essential to counteract shrinkage by providing additional molten metal to compensate for the material's contraction during solidification. Identify casting defects such as porosity, cracks, and surface irregularities is crucial for ensuring the quality of the final product. Additionally, managing residual stresses resulting from the cooling and solidification process is necessary to prevent material failure or deformation. The topic also delves into bulk and sheet metal forming processes, which involves plastic deformation and yield criteria. These processes alter the shape and size of metallic material through mechanical forces. Hot and cold working processes are fundamental, with hot working occurrence at elevated temperature and cold working at lower temperature to manipulate material properties and form desired shape. Estimating load for bulk forming processes such as forging, rolling, extrusion, and drawing involves understanding the principle of material behavior under pressure and temperature. Similarly, in sheet metal forming, which includes shearing, deep drawing, and bending, applying appropriate force and understanding material responses are crucial for achieving desired shape and dimensions. Moreover, the topic covers the fundamental of powder metallurgy, a method involved in production of metal powder and their subsequent shaping into component through compaction and sintering. This techniques allows for creation of intricate shapes and structure not easily achievable through conventional methods. In summarized way, the conventional manufacturing processes discussed encompass casting and molding techniques, heat transfer principle, solidification mechanism, consideration of preventing defects and managing stresses, bulk and sheet metal forming, hot and cold working processes, load estimation, and fundamental of powder metallurgy. These techniques correctly enable the transformation of raw material into the wide array of functional product across various industries. So let's come into the second part of this module is joining processes and metal cutting. Metal cutting is a fundamental process in manufacturing that involves shaping and removal material to create precious component. It encompasses various aspects including Single and multi-point cutting method, orthogonal cutting, force component, chip formation, tool wear life, surface finish, machinability, cutting tool material, cutting fluid, coating, machining techniques like turning, drilling, milling, and introduction of CNC machining. Additionally, it covers additive manufacturing techniques such as rapid prototyping and rapid cooling, as well as joining as fastening processes like welding, brazing, soldering, design consideration in welding, solid and liquid state joining processes, and adhesive bonding. Single and multi-point cutting techniques are essential methods used to shape material. Orthogonal cutting involves a single point cutting tool perpendicular to the workpiece, analyzing various force components influencing the process. These forces impact chip formation, affecting the quality of the final product. Understanding the tool wear and tool life is crucial as it directly affects the production cost and quality. Surface finish and integrity play a significant role in determining the final product's functionality and aesthetics. Factors affecting machinability such as material properties and cutting parameter need consideration for efficient metal cutting processes. Machining processes like turning, drilling, milling, and finishing methods utilize specific techniques to shape material effectively. These processes involve removal of material through rotary and linear movements, achieving various geometries and surface finishes. The advent of CNC machining has revolutionized manufacturing by employing computer control systems for precise and automated operations, allowing for complex shape and high production rate. Additive manufacturing techniques including rapid prototyping and rapid tooling offer innovative ways to create components layer by layer using material like polymer, metal, and ceramics. These methods enable quick and cost-effective production or prototypes or tooling without traditional machining constraints. Joining and fastening processes like welding, brazing, soldering, solid and liquid state joining, and adhesive bonding are crucial for assembling components. Understanding the physics of welding such as heat generation and metal properties the essential for achieving strong and durable joints. Design consideration in welding such as joint design, pre-weld and post-weld treatment, and selection of appropriate welding techniques significantly impact the final joint quality. Solid state joining process involves bonding without reaching a melting point, whereas liquid state joining uses molten material to create bonds. Brazing and soldering are examples of the liquid state joining, requiring lower temperature compared to welding, suitable for joining dissimilar metal or delicate component. Adhesive bonding involves using adhesive to create bonds between substrates. This method offers advantage in joining dissimilar material and distributing stress more evenly across the joint area. In summary, metal cutting encompasses wide range of techniques and processes crucial in manufacturing. Understanding these methods, material, and consideration is vital for achieving precise, efficient, and high quality production across the various industries. Thank you.